Have you ever stopped to think about those invisible hands, the ones quietly shaping our digital world? These foundational ideas, they're so deep in the software we use every day, we might not even notice them.
Right.
Today, we're pulling back the curtain on one of those, well, unsung architects, Martin Fowler. So our mission in this deep dive is to really explore the mind of Martin Fowler.
Yeah.
As a British software developer, author, public speaker, and figure out how his, well, profound ideas have influenced not just how we write software,
Yeah.
but critically, how we manage data,
Yeah.
often without us even realizing where those best practices actually came from.
Exactly. And we've got some great sources lined up for this. We'll be using his Wikipedia biography, to get a good background on the man himself.
Okay.
And then we'll really dig into how his specific contributions fundamentally shaped so many of the data management patterns that are, well, pretty standard today.
Think of this as your essential shortcut to getting informed on a truly foundational figure in tech. We're going to uncover some maybe surprising facts and definitely some essential nuggets about how his concepts got so embedded in today's tech. So let's unpack this. So who is the mind behind these foundational ideas? Maybe we can trace Martin Fowler's journey a bit from his early days.
Sure. So he was born in Walsall, England. That was back in 1963.
Okay.
Graduated from University College London in 86. And then a few years later, 1994, he made the move over to the United States, settled near Boston, actually.
Right, Boston. And his career path, you mentioned versatility earlier.
Yeah, it really highlights that. He started working with software way back in the early 1980s.
Wow, early days.
Yeah. And right out of university in 86, he joined Coopers & Lybrand, stayed there till 91.
Mm-hmm.
Then fast forward to 2000, he joined ThoughtWorks, the big systems integration and consulting company.
Oh yeah, ThoughtWorks, sure.
And eventually became their chief scientist. So it shows this deep commitment, really, to both the hands-on stuff and the sort of theoretical leadership side.
That's quite a journey. Given that, what were the core areas, the expertise that really, put him on the map?
Well, he became really well known for his work in object-oriented analysis and design.
Okay.
UML, that's the Unified Modeling Language, of course, software patterns, and agile software development methodologies, including extreme programming, XP.
Right.
What's interesting is how these different areas often sort of came together in his work. He had this really holistic view of software development.
Sounds like he was right there at the forefront when things were shifting in software thinking. What were some of his earliest, maybe most significant contributions, the ones that laid the groundwork?
Absolutely. I mean, his 1999 book, Refactoring, that really popularized the whole practice of improving existing code.
Ah, refactoring, yes.
Yeah.
Huge influence.
Huge. Then in 2004, he introduced a new architectural pattern, presentation model. And importantly, he's a key member of the Agile Alliance. He was actually one of the 17 signatories.
Oh, really?
Who helped create the Manifesto for Agile Software Development back in 2001.
Wow, okay. I knew he was involved in Agile, but didn't realize he was one of the original signatories.
Yep. And he also played a really big role in popularizing the term dependency injection as a form of inversion of control. These were, genuinely game-changing ideas at the time.
Definitely. Now, beyond the books and manifestos, he also pioneered this unique way of sharing his ideas. Something he calls a bleaky. What is that exactly, and how did it become such a definitive resource?
Right, the bleaky. It's basically a blend, a blog and a wiki.
Okay, interesting name.
Yeah, it's not just quirky, though. His bleaky entries have this reputation. They've almost become the go-to canonical explanations for really complex concepts across the whole industry.
So like the final word on certain topics.
Kind of, yeah. What makes them so powerful is how they distill these intricate ideas into really clear, authoritative articles, including a lot related to data persistence and architecture. It's like this dynamic, constantly evolving encyclopedia of best practices.
He's certainly incredibly prolific with writing. 9 books on software development, you said.
Yeah.
From 96 up to 2018.
That's right.
Titles like UML Distilled, Patterns of Enterprise Application Architecture, Domain-Specific Languages. How have these books shaped how we think about software?
Well, let's maybe zoom in on refactoring first,
Yeah.
because its impact is just so foundational.
Okay.
Refactoring, essentially, it's about improving the design of code that already exists, crucially, without changing its external behavior, what it does.
Right, so it's not just tidying up.
Not at all. It sounds simple, maybe, but before Fowler really popularized it, developers often just kept piling on new features without cleaning up underneath, leading to code rot.
Uh-huh. Been there?
Yeah. Fowler made the case that actively improving the code's design should be a continuous process, part of the job.
So if I'm getting this right, it's not just about making the code prettier, it's about making it healthier. How does that connect to data, though? The book's about code, right?
Exactly. That's a great question. While the book is focused on code, the practice itself, indirectly but really profoundly, improves data integrity.
How so?
Well, by encouraging well-structured, clean code, you inherently prevent things like bad database queries, you stop data getting accidentally corrupted,
Okay.
and you reduce the chance of bugs messing with your data just because the application logic is messy or poorly designed. It's about building robust applications that interact cleanly with the database.
That makes perfect sense. So beyond fixing existing code, Fowler also championed this other concept. Sounds a bit niche maybe, but it's become widespread. Domain-specific languages? DSLs.
Yeah.
What are DSLs? Why are they important?
Right, DSLs. They're basically composable programming languages, but focused on a specific job or domain.
Like a specialized tool.
Exactly. Think of it like a specialized hammer instead of the whole toolbox. They have limited expressiveness, they can't do everything, but what they can do, they do really well.
What's the big advantage of something having limited expressiveness? That sounds kind of counterintuitive.
It's powerful because of that limit, you see. They can massively boost productivity because you don't need to understand a full, complex programming language for certain tasks.
Okay.
They also give you a way to communicate better with domain experts, the business folks who understand the problem, but maybe not the code.
Ah, like a common language.
Precisely. And crucially, they separate the how, the technical implementation details, from the what, which is the business logic or the intent of the past.
That separation sounds incredibly useful. But there must be trade-offs, right? It can't be all upside.
Oh, definitely. You're right. There are costs. You might have to learn a new, very specific language. Sometimes you need to build special tools to, parse and run it. There's a risk of siloing, where different teams use different DSLs and maybe struggle to integrate things later. And sometimes the abstractions just aren't a good fit for every single task, and you end up having to drop back to a general-purpose language anyway.
And Fowler didn't just talk about them in theory, did he? He broke down the practical types.
Yes, exactly. He distinguishes between internal or embedded DSLs. These are basically subsets of another language like Ruby or Lisp often use.
Okay.
And they run using the tools for that main outer language. Then you have external DSLs. These are standalone languages. You often need things like parsers and lexers to handle them.
Gotcha. Any examples?
Sure. He mentions common things you might already use, like CSS for styling websites. That's a DSL.
Of course.
GraphViz for specifying graphs. Even Make, the build tool used in countless software projects. You've probably used a DSL without even realizing the term.
Yeah, CSS definitely. Okay, so this is where Fowler's influence really gets deep, especially for anyone dealing with information, with data. As you said, he isn't primarily known as a database guy, not in the traditional sense, but his influence on how we actually manage data is profound and maybe surprisingly indirect for many people.
Yeah, what's fascinating is he's really this crossover figure. He wasn't inventing new database theories, like a Cod or a Stonebreaker.
Right.
Instead, what he did brilliantly was translate these complex architectural and design ideas into clear, usable concepts, especially for enterprise software, which, let's face it, inherently deals with tons of data.
So he made the complex accessible.
Exactly. He made these sophisticated patterns understandable and applicable, which was absolutely crucial for the explosion of complex business applications we saw.
In his 2002 book, Patterns of Enterprise Application Architecture, that became like a Rosetta Stone for integrating business systems and their data.
That's a great way to put it, yeah. It provided these clear, systematic descriptions of different ways to architect the data source layer.
Okay.
So let's break down some of these key data management patterns. You probably encounter these daily, even if you don't call them Fowler patterns. These first few are mostly about how applications talk to databases.
All right, let's hear them.
Okay, first up, the table data gateway. So the core idea here is a single class, a component that acts as the gatekeeper for all database access for one specific table or view.
On a class per table.
Essentially, yeah, and it's influenced today. Well, this basic idea is baked into most ORM tools, object-relational mappers like Hibernate or Entity Framework.
Okay.
It centralizes the query logic, cuts down massively on duplicate SQL scattered everywhere. It brought this new level of predictability, control, made large apps way more robust, easier to change.
Makes sense. What's next?
Next, the data mapper. Now, the essence of this pattern is separating your in-memory objects, the things your application works with, from the database schema itself.
How does it do that?
It acts like a dedicated translator between them, mapping data back and forth so neither side needs to know the specific details of the other. Your app objects don't know SQL. The database doesn't know your objects.
Okay, decoupling them.
Exactly. And it's modern relevance. This is the absolute foundation of how many advanced ORM designs work. It's essential for scaling apps where the database schema might need to change without forcing you to rewrite tons of application code.
Crucial for evolution. Got it.
Then we have active record. This pattern defines objects that basically wrap a row in a database table,
Oh, wait.
and they add behavior. So the object's methods themselves actually read or write directly to the database.
So the object knows about the database.
Yeah, they're more tightly coupled. Its impact today, it's still really common, especially in frameworks like Ruby on Rails, Laravel.
Right, Rails uses it heavily.
Yep. Particularly good for smaller CRUD systems. Create, read, update, delete. Fantastic for rapid development.
Yeah.
Maybe less popular in really highly complex systems because of that tighter coupling.
Understood. And the last one in this group.
And finally, for this set, the repository pattern. This one's a higher level abstraction. It manages collections of objects, and it abstracts away the nitty-gritty details of how the data is actually accessed.
So you don't talk to the database directly.
Right. You ask the repository for an object or to save an object. You don't care how it does it. Could be SQL, could be a file, could be a web service.
Ah, okay. More abstract.
Exactly. It's modern relevance. It's very often used in domain-driven design, DDD, and it forms the basis of how many robust service-oriented APIs handle data retrieval. It gives developers a much cleaner interface to work with data collections.
You can really see how these first few tackle different ways to bridge that gap between the application and the database, from direct table access right up to abstracting collections. But Fowler's insights go even further, don't they? Especially when we get into distributed systems data integrity challenges.
Exactly right. Building on those foundational access patterns, Fowler also illuminated concepts that have just fundamentally reshaped how we approach data in large-scale distributed systems. Big stuff.
Like what?
Okay, first, event sourcing. What is it? Well, instead of just storing the current state of something.
Like the current customer address.
Right. Instead of just that, you store the full sequence of events that led to that current state.
Like customer created, address updated, order placed.
Precisely. Think of it like an accounting ledger. Every single transaction is recorded, not just your current bank balance. You get this complete immutable history.
Immutable.
And its impact today, it's core to systems needing strong audits, like financial systems, very common in append-only data stores, used in blockchain apps, real-time analytics pipelines. Anywhere beta lineage is critical. It gives you this amazing audit trail and lets you do powerful historical analysis.
Wow, that's a different way of thinking about state. What else?
Then there's CQRS. That stands for Command Query Responsibility Segregation.
Okay, C2RS. Bit of a mouthful.
Huh, yeah. What it is. This pattern basically splits your data model. It separates the operations for writes, those are called commands, from the operations for reads, called queries.
Separate paths for changing data versus just looking at it.
Exactly. And often these are backed by completely separate storage systems, each optimized for its job. Maybe a relational database for writes, something else for reads.
Why do that?
It's not just about performance, though that's part of it. It's a recognition that the needs of reading data are often vastly different from the needs of changing it, especially at scale.
Okay. Impact today.
Huge. It powers many high-scale microservices where you might have, say, way more reads than writes. Think e-commerce product catalogs. It also enables polyglot persistence using different database technologies for different needs, like write to PostgreSQL for transactional safety, but read from Elasticsearch for super fast searching.
That makes a lot of sense for complex systems.
And connecting this to the bigger picture, especially with microservices booming, data architecture is just critical now. Fowler was a strong advocate for database per service.
What does that mean?
Simple idea, profound implications. Each microservice owns its own database. No direct sharing of databases between services.
No reaching into another service's data store.
Absolutely not. It's impact today. This pattern prevents those awful data coupling disasters you see in large organizations where changing one thing breaks 10 others. It forces teams to define clean APIs for data exchange, reduces accidental corruption. It's really all about service autonomy.
Essential for microservices to work properly, really.
Totally.
And finally, there's a clever approach for managing those big, scary system transitions. Migrating data, phasing out old tech.
Ah, yes, the strangler fig pattern. Love this name.
Me too. Why is it?
So the idea is you gradually replace an old, often monolithic system. You do it by building new features around it in parallel, and you slowly redirect traffic or calls to the new system piece by piece, effectively routing around the legacy code and data until the old system is, well, strangled, it withers away because nothing uses it anymore, and then you can safely retire it.
Like that fig vine growing over an old tree.
Exactly the analogy. It's impact today. It's used all the time in complex data migration projects. Think moving off legacy mainframes or old on-prem databases onto modern cloud data platforms. It lets businesses evolve without that terrifying Big Bang rewrite where everything stops.
A much safer approach for complex migrations.
Definitely. So what does this all mean for you listening? The really fascinating part is, like we said, Fowler didn't necessarily invent all these patterns from scratch. Many existed in bits and pieces, different names, different places.
Right.
But what he did was give them clear names, precise explanations, practical examples. He made them stick. His books, his Bleaky, they became the standard references people turn to.
He codified them.
Exactly, codified and popularized them. Today, you find these patterns just embedded everywhere in frameworks, cloud architecture guides, even NoSQL designs, and often nobody explicitly says, oh, that's a Fowler pattern.
They're just the way things are done.
Pretty much. His legacy is really about making these best practices accessible, acting as this crucial translator between the maybe abstract world of software architecture and the very practical world of building robust systems that handle real data day in, day out.
Martin Fowler's influence, it really demonstrates that true impact isn't always about inventing something totally new from whole cloth, is it? It's often about clarifying, popularizing, explaining complex ideas so clearly that they become broadly accessible, broadly applicable.
Yeah.
And his work just continues to quietly underpin so much of the software and data infrastructure we all rely on.
It really does. And this brings up an interesting question maybe for you to think about. How many other foundational ideas, these sort of invisible influences, are shaping the technologies you use every day? What other Rosetta Stones or Bleakies are out there, clarifying complex fields, quietly becoming the standard, maybe without you even knowing their origin?
That's a great point. We hope this deep dive into Martin Fowler's contributions gives you, well, a new lens, a new way to view the architecture of the digital world around us.